Hey y'all, and welcome to episode 4 of the Basics of Building an FTC Robot, presented by 17097 Protostars. Last episode, we talked about how to pick parts for your robot. We covered types of custom parts, motor specs, servo types, and wheel options. But this episode, we're going to discuss the actual building process for your robot, and what kind of questions you may have during building. So let's get into it. The first thing that we are going to go over is the idea of sub-teams. Our team, Protostars, has 3 sub-teams: the build team, the programming team, and the outreach and notebook team. Each team works on a portion of the task for that season, but there is often crossover between sub-teams. For example, I'm the captain of the build team, but I'm also part of the programming team. This is something that we found works for us, and we thought we'd recommend it to you. Next, let's look at goBilda kit connections. I have in front of me some examples of goBilda components, from U-channels to servo mounts to cable connections. These are all components that are available on goBilda's website. We are not sponsored by goBilda, we just find their components to be very straightforward to work with. First, let's go over frame pieces. There are a few different types of frame pieces: U-channels, C-channels, beams, and plates. U-channels are the largest and arguably strongest components. We use these on our robot Adam, and they form most of the shape of Adam. Then there's C-channels. C-channels are similar to U-channels, but they have shorter walls than U-channels. We used these on the lift system of Adam, along with the inside panels of Pulsar. The third type of frame pieces is beams. Beams are much smaller compared to the channels, so they can be used for smaller areas of the robot. Some of these holes are threaded and some holes are not. And finally, there are plates. And within the category of plates, there are 2 subcategories: grid plates and pattern plates. Grid plates, like the name suggests, are just holes in a grid pattern. On the other hand, pattern plates have the same layout of holes as the C-channels and U-channels. Which one should you use is just based on where it is on the robot and what you're attaching to it. Next, let's look at the types of motor mounts. There are 2 main types, and our team has had equal success with both. The first is clamping mounts. For this type, you slide the motor into the circular gap and then tighten the bolts on the top, and that clamps down on the motor. The advantage of these is that you can tighten the clamp down on any area of the motor to control how far the motor is from the mount. The other type of motor mount is just pattern mount. Just like the pattern plates, pattern mounts have the same arrangement of holes as channels. You'll see on a motor there are holes on the face. These holes line up with the patterns, and it makes it easy to attach the channels, mounts, or plates. This is how we attached our drivetrain motors on our 2021 to 2022 season robot, Adam. We used what we call stick legs to avoid damage to the underside of the robot, and the motors are directly screwed into the patterns on the legs. This was very easy to attach, and the connections never went loose. Now, let's look at different motion components. Motion is a category on the goBilda website. This category includes all the parts that move but are not electronic. For example, gears. Gears are interesting because they switch the direction of rotation from the original. There's also planetary gears that switch the direction and the axis. If the first gear spins clockwise, the second spins counterclockwise. This is definitely something that you need to keep in mind when programming, but not so much when actually building. However, to avoid that math later, you can use sprockets and a chain. They accomplish a very similar task as gears, but they don't switch the direction. Both sprockets rotate in the same direction. Another benefit to sprockets with a chain is that there can be a large distance between the sprockets. You just add more links to the chain. Something very similar to sprockets and chains is timing belts. Timing belts are called timing belts because they synchronize the movement between two parts. And they are very functional, and the belt itself is rubber. This makes them perfect for conveyor belts to pull in any sort of object. For example, we use them to pull in the foam rings in the 2020 to 2021 season Ultimate Goal. The main disadvantage, though, is that unless you 3D print your own belts using a flexible material, there are only a few choices for lengths of timing belts, and you can't just add links like you can with a chain. However, if you do have a 3D printer, which we'll get to in the next video, you can use a flexible material such as TPU to print a flexible belt of any size. Also, if you 3D print it, you can print it in whatever color you want, as opposed to the simple black rubber that you can buy it in. And finally, let's look at the cable connections. There are a few different types of cable connections that you will need to understand in robot FTC building. We are going to go through these in order of the circuit. That means we'll start with the battery and power connections. These have just two ports, a positive and a negative port. These are designed so you can plug them in positive to positive, negative to negative, and you can't accidentally plug them in opposite. This kind of connection connects the battery to the power switch to the control hub, and if you have one, the control hub to an expansion hub. You can purchase different lengths of these cables. The next kind of cable connection is the motor ports on the hubs. These ports look like a white square with a little white tab on it. There are 6 motor ports on each hub. However, this is not the same connection as the motors themselves, so you have to use an adapter. The adapters have a white box connector on one end and 2 cylindrical connections, red and black, on the other side. This connection is the male connection match to the female connection on the motor. A big difference between this connection and the power connection is that you can actually plug them in backwards. You can plug them in positive to negative, negative to positive. This will result in the motor spinning the opposite direction than the program says, but this can be helpful sometimes. If you want to make a motor spin the opposite direction, but you're too lazy to change the program, you can just reverse the 2 connections. It's hard to admit, but we've done this a few times. Another type of cable connection is the motor encoder. This has 4 wires, a black, a white, a blue, and a red. This cable is not required, but very helpful. If you want to make your robot go a given distance rather than a given amount of time, you'll need an encoder. These plug in one end to a motor and one end to the hub. Make sure that the encoder wire plugs in right next to the motor port that it is plugged into on the other end. The 4th type of cable connection is the servo connection. This kind of cable has 3 wires. One is the ground, one is the power, and one receives directions. These wires plug directly into the hubs, no adapters necessary. There are 12 ports for servos on each hub. Often, you might need extension wires for any of these types of connectors. These are all available from FTC supported businesses. The wires, motors, and servos we use are from goBilda. I hope you enjoyed this episode of the basics of building an FTC robot, and I hope to see you next episode. Thanks, and good luck building. Before you head out, be sure to subscribe to our channel for more content. We're going to be posting more and more videos as we go. And be sure to hit the like button if you enjoyed. And be sure to share. I'm sure there's a lot of people out there that would love to see this. So, thanks. See you around. Okay.
Anybody else hear that?
Hear what? The water running? I think somebody flushed a toilet. Please put that in the bloopers. Is YouTube gonna what's the term?
Demonetize us?
Demonetize us?
No, have you seen the videos on YouTube? There's so much words in there.
I know. There's a lot worse that.
Demonetize you.
What?
Toilet.
They demonetize you
I didn't say toilet.
For saying that someone flushed the toilet.
You're pretty terrible.
You have
Demonetize.
you even have.
Are you recording?
Subscribers to get Oh, money. Oh, stop recording.
I was like, are you recording your dad? All right, well, thank you for doing the scrolling. It worked great. Thanks for
Other than when it runs away.
Thanks for recording, Isaac. Thank you for recording camera. Thank you for displaying screen. Thank you, table.
What about the light?
Thank you, light, for shining brightly on me. Is that what you wanted?
Yes,
You weren't recording though, were you?
I am.
Oh, really? And this is running too. Hey, that's pretty good. Less dirty looking. Yeah, it's like a nice cool blue, a cool gray.